All right, we got 2.5, which is average rate of change. All right, so here we've got a function f of x shown on the right-hand side. Evaluate the following. So function notation, we've seen this before. F of 0, that would be right here. Output is 1. F of 4, 1, 2, 3, 4. These are all the points that are nicely plotted. That's 7. F of 7 is here. That's 10. And then F of 13, all the way up there, is 15. Okay, you're talking about the outputs at all of those inputs. Find the change in the function over each of the following domain intervals. So from 0 to 4, the change in the function was 7 minus 1. It went up by 6. From 4 to 7, so that would be 10 minus 7, which would be 3. And then from 7 to 13, it went from 10 to 15, so that change was 5. All right, it says, why can't we simply compare the changes in f to determine over which interval the function changed the fastest? Well, if you look at each of those intervals, they're not the same length, right? 0 to 4 is only 4 units. 4 to 7 is 3 units, and 7 to 13 is 6 units. So because the change in x is not the same, so they can't compare them. So we calculate what we call as the average rate of change. Average rate of change over the interval determines the change in f, and if you look down below, the change in f over the change in x. So the change in your outputs over your change in inputs. All right, so from 0 to 4, the change in outputs went from 1 to 7. So you would do change in f over change in x. It would be 7 minus 1 over 0 minus 4, which is 6 over 4, or 3 halves. All right, from 4 to 7, well, my outputs at 4 and 7 were 7 and 10. So 10 minus 7 over 7 minus 4, which is 3 over 3, which is 1. And then the last one, average rate of change from 7 to 13. What was that, 15 and 10? Yes. Let me just fix that 15. So you get 5 over 6. All right, so which interval had the greatest average rate of change? The greatest would be the 3 halves, okay, because that's 1.5. All right, so now we can actually compare them because you're taking into account the change in x. Okay, so it's increasing the fastest over its interval. All right, so what you want to know is average rate of change is your change in output over your change in input. Okay, change in f over change in x, which you've heard this before. It's slope, right? It's the slope of a line segment. So even though these aren't linear on this function, we can look at the slope of a segment that would contain those 2 points, that contains these 2 points, that contains these 2 points, and you can see that they're getting less steep as we go. All right, so the average rate of change over that interval is changing. All right, so here it says the table below represents a linear function. If it's linear, then it has a constant slope or average rate of change. Fill in the missing entries. So if this is linear, we can find an equation for it, right? We've got 2 points here. We've got this point, which is 1 comma negative 5, and we have this point, which is 5, 1. We can write an equation that has those 2 points on there. So change in y over change in x, the slope is the same throughout this equation. So the slope would be 6 over 4, or 3 halves. Then we can go y equals mx plus b. Put in either one of those points. I'm going to put in the 5, 1. Put in my slope of 3 halves and find my y-intercept. I do 1 minus 15 halves, sorry, that would end up being negative 13 halves. So I have an equation of y equals 3 halves x minus 13 halves. All right, so now we can use that equation and find those other missing x's and y's. What I'm actually going to do, I'm going to use my calculator, right? Go to y equals. I can put in that equation. So it was y equals 3 halves x minus 13 halves. Oops. Shoot, that was wrong over here. There we go. Now I fixed it. So 3 halves x minus 13 halves. If I go to my table, what do I need? I have an x value of 11. So, right, my table here has an x coordinate of 11. So let's go to this table to where x is 11. And when x is 11, y is 10. So I can fill in my table now. I can put 10 in there. And then 45. Well, let's go to the next one. The y value is 22. So where do we have a y value of 22? When an x value of 19. And then lastly, x value of 45. We can get there, and it is 61. Okay, so write your equation. As long as you know it's linear, you can write that equation and then come up with it. All right, we will go over any questions you have tomorrow on average rate of change, but it's really just slope, right? Slope of a line segment that connects those 2 points on your function. Change in output over change in input.